Hello everyone, Tom from EveryStepCalculus.com, EveryStepPhysics.com. In this video I'm going to show you how to do limits at infinity or zero, where we might have to use L'Hopital's rule. So let's do it. Index 8 to get to my menu. And we're going to scroll down to limits. I'm going to use second and the cursor to get there quick a couple times. Otherwise we can just scroll down and hold the cursor and or we can press it each time. There we go, limits here. And this one is going to go to 0, so we're going to do compute the limit. If it's going to infinity, you'd use limits to infinity. But x equals 0, going to 0, so we're going to compute the limit that way. You have to press alpha before you enter anything in these entry lines here. So we're going to put the function in here, alpha, second, sine of x, close off the parentheses, divided by x. And x equals alpha 0. I always show you what you've entered. You can change it if you want, if you made a mistake. I say it's okay. So here's one of the tricks with this insane L'Hopital's rule. Because at x equals 0, the numerator is 0 and the denominator is 0, we have to use L'Hopital's rule to find the limit. These things never happen in real life, as usual in calculus, so computing limits to infinity and etc. Waste of time as far as I'm concerned, but that's calculus. So we have sine of x and x, we say that's okay. Now at x equals 0, sine of x equals 0 and x equals 0. So then we continue on with L'Hopital and do the derivative of each, the numerator and the denominator, which is this. And so then we look at that again. Now they equal 1, but we're all done now because it does not, I ask you that, does the denominator and the numerator still equal infinity or 0? And we saw it equals 1, both of them, so we have to say no here. When we say no here, it gives us the answer. Answer is, the limit is 1. I'm going to do another problem here quick for you. Go back to and do a new problem. This one's going to go to infinity, so we're going to choose number 4, limits to infinity. And we're going to enter the function here, alpha, second, log of x, close off the parentheses, divided by x. And we're going to do that at positive infinity. So here's what you've entered so far. We say it's okay. We're going to choose number 1. And because at x equals infinity, the numerator is infinity and the denominator is infinity, so we have to use L'Hopital's rule. I'll show you what you've entered here, and then we're going to compute it at infinity. At x equals infinity, log of x is equal to infinity, and x is equal to infinity. So we do the derivative again of it, which is this. And now at infinity, 1 over x equals 0, and infinity at 1 is equal to 1. So we say now it's not equal to infinity, or both of the numerator and the denominator is not equal to infinity or 0. So we choose number 2. And the limit is equal to 0 here, 0 over 1. I'm going to do another one. This is limit to 0 again, so we're going to choose number 2. Enter the function, same function, just to show you that this is a trick one that might be on a test or somewhere. And we're going to enter the thing again, enter the function again. excuse me, x, close out the parentheses, divided by x as x approaches 0. Show you what you mean. We say it's okay. Now this one, the limit is negative infinity over 0 equals negative infinity. So this trick, we caught that trick too, and it's in my program. Pretty neat, huh? Everystepcalculus.com. Go to my site and subscribe so you can see more movies of how to do these things. Or go to the menu and see it. Click on whatever you're interested in. Have a good one.